Dear students, last time you have seen kinetics of opposing reactions. Let us see today kinetics of consecutive reactions. Before discussing the kinetics of consecutive reactions, let me tell you at first what are consecutive reactions. So, the chemical reactions which occurs in two or more than two consecutive steps. Subsequent steps are known as what? The consecutive reactions or sequential reactions. So, the hypothetical example, we can very easily understand what are sequential reactions or consecutive reactions with the help of one simple hypothetical example. Let us suppose in a chemical reaction, reactant A is converted into B at first and later on B is converted into C. So here the final product is C, but here this reaction occurs in two stages. In first stage A is converted into B and in second stage B is converted into C. So the chemical reaction in this particular case, this chemical reaction involving what? The conversion of A into what? C. And this conversion occurs in two stages. In first stage, A is converted into B, and in second stage, B is converted into C. So, in short, this chemical reaction involves two stages. In first stage, in stage 1, A is converted into B, and in second stage, B is converted into C. So let us suppose the rate constant of first stage is K1 and the rate constant of second stage reaction is K2. So here this type of reaction is known as consecutive reaction or sequential reaction. So let us have few examples of consecutive reactions or sequential reactions at first, and then we shall see what the kinetics of consecutive reaction. The best examples of consecutive reactions or sequential reactions are: number one, decomposition of the thermal decomposition of the thermal decomposition of acetone. This is what the best example of consecutive reaction or sequential reaction. The thermal decomposition of acetone. The thermal decomposition of acetone occurs in two stages. Let us see how thermal decomposition of acetone takes place in two stages. In stage 1, acetone. Stage 1, acetone, CH3, C double bond O, CH3, acetone. When acetone is heated, it gives CH2 double bond C double bond O plus CH4. This is what stage 1. And in stage 2, this CH2 double bond C double bond is converted into 1 by 2 C2H4 plus CO, carbon monoxide. So this is what the second stage. So in this way, the thermal decomposition of acetone occurs in two stages. in first stage, when acetone is heated, it gives these two products, and these two products in second stage gives the final product C2H4. So here when we look at this reaction, we will see in this case in first stage the reactant reacts and gives the product, a new product, and that new product later on gives the final product. So in this way, this reaction takes place in two stages and therefore is known as consecutive reaction or sequential reaction. Sequential reaction, name itself indicates that the sequence of reaction or the completion of reaction occurs in a sequence. In first step, reactant is converted into a product, and whatever new product generated in first stage is later on converted into the final product, and hence in second stage the product generated in first stage acts as a reactant. So in this way, this reaction takes place in two consecutive steps and therefore known as consecutive reaction or sequential reaction. So let us have one more example of consecutive reaction. The another example of consecutive reaction is the best example of consecutive reaction, the hydrolysis of diethyl succinate, the hydrolysis of diethyl succinate. The hydrolysis of diethyl succinate occurs in two steps. Let us see how the hydrolysis of diethyl succinate occurs in two steps. In step 1, diethyl succinate CH2 COO C2H5 2 plus H2O diethyl CH2COO C2H5 di-2-ethyl succinate. Diethyl succinate, I can write it like this so that you will understand. CH2 CH2 COO C2H5 C2H5 COO C2H5 diethyl di-2-ethyl succinate plus H2O, it gives CH3COOH CH2COO C2H5 ethyl, or we can say this is monoethyl succinate plus C2H5OH. So in first stage, diethyl succinate, this gives what this product, and in second stage or stage 2, this is what stage 2, stage 1. In stage 2, this product generated in first stage gives the final product CH3, sorry, CH2, COOH, CH2, COO, C2, EH5 plus